Hello, everybody, and welcome back. We're looking at question number 7 on part 1 of our contest from Alberta. A square pigeon coop is divided by interior walls into 9 square pigeon holes in a 3x3 configuration. Each of 2 pigeons chooses a pigeonhole at random, possibly the same one. So we've got 2 pigeons, they both pick a hole at random. Okay. The probability that they choose 2 holes on opposite sides of an interior wall is. Okay, what exactly do they mean by that? So, got our pigeon coop. So, if pigeon 1 picks here and pigeon 2 picks here, they are on opposite sides of this interior wall. Is that what we are to understand? Or does the whole thing count as the wall, and so this up here also is opposite that same wall? I don't think that's the case. I think it's the first scenario we've got. Okay. Now, there's a fair degree of symmetry, so what I'm going to do is I'm going to break this into cases. So, suppose our first pigeon comes along and picks the middle. Right? There's a 1 out of 9 chance that that happens. Now we're going to have the second pigeon come along. What possible spots could the pigeon pick that are on opposite an interior wall? Well, the pigeon could go here, 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 or here. That's it. So those are 4 spots out of 9, because the second pigeon could have picked any of those spots, including this one, the middle one. So 4 out of 9 times, if the first pigeon's got the center square, then the second pigeon will end up in the spots that they agree with, or that they think are favorable. Now, suppose our first pigeon picks a different kind of spot. So let's say pigeon number 1 picks a corner. Okay? So I'm going to do all this sort of analysis and work looking at the top corner, but it would be the same thing, if the first pigeon goes here and the second pigeon goes here, that's the same as if the first pigeon went here and the second pigeon went here. We're just sort of rotating around. Or the second pigeon goes here and the first pigeon goes here. Okay? So we're just going to look at the corner there, but there are 4 corners, so it's a 4 out of 9 chance that the pigeon winds up in a corner. And if it's in a corner, what are the chances that the second pigeon, where can the second pigeon go? Well, here or here, that's it. So 2 out of 9 chance that relative to where the first pigeon went, the second pigeon is opposite an interior wall. We've got one other type of square, and that's an edge square, or a side square. So maybe pigeon number 1 lands here. Again, there are 4 of these edge squares. So we're doing the same sort of thing 4 times. So 4 times 1/9. The chances he's in one of those spots. And where could the second pigeon go? 1, 2, 3 spots. So 3 out of 9. I know I could simplify that to 1/3, but I think it's probably going to be a little easier for the calculation. So 4 out of 81, 8 out of 81, and then 12 out of 81. For a total probability of 24 out of 81. So those are the chances that the pigeons have this nice relationship. Okay. I'm not. 24 is a multiple of 3. So divide by 3 on top and bottom. 8 out of 27. That looks a little more like the answers I'm seeing here. So we get D. Okay. So the answer to question number 7 is D. And we can get ourselves ready for question number 8. We'll take a look at that next time.